This is The Sleepwalkers by Arthur Koestler, subtitled A History of Man's Changing Vision of the Universe. And this is my copy that I bought in 1969, so it's seen a bit of wear and tear over the years. Let me just read one of the reviews on the back because I think it gives a good overview of what this book's about. It says, "The greater part of this massive work is a close and valuable study of Copernicus, Tycho Brahe, Kepler and Galileo." He writes tensely, with passion, as though personally involved about events that took place more than 300 years ago. And I think that captures very, very well for me both the kind of intellectual but also the emotional impact of this book. It stayed with me over half a century now, and I still rate it as one of the best books I've ever read. Koestler starts off with a history of the different sorts of cosmologies that we know about, theories of how the universe worked. And he goes back and he says, I'll read from here, he says, "The world of the Babylonians, Egyptians and Hebrews was an oyster with water underneath and more water overhead, supported by the solid firmament. It was also of moderate dimensions and as safely closed in on all sides as a cot in a nursery or a babe in the womb. The Babylonians' oyster was round, the earth was a hollow mountain placed at its centre, floating on the waters of the deep. Above it was a solid dome covered by the upper waters. The upper waters seeped through the dome as rain, and the lower waters rose in fountains and springs. Sun, moon and stars progressed in a slow dance across the dome, entering the scene through doors in the east and vanishing through doors in the west." And we know about various these models. People talk about the world being on the back of a tortoise and all that sort of thing. And lots of these different models applied or were expounded in history. But in addition to these, what we now see as rather absurd models of how the universe works, there were others. Koestler says here, some 6,000 years ago, when the human mind was still half asleep, Chaldean priests were standing on watchtowers, scanning the stars, making maps and timetables of their motions. Clay tablets dating from the reign of Sargon of Akkad, around 3,800 BC, show an already old established astronomical tradition. The timetables became calendars which regulated organised activity from the growing of crops to religious ceremonies. Their observations became amazingly precise. They computed the length of the year with a deviation of less than 0.001% from the correct value. In this respect, theirs was an exact science. And this is the kind of interesting contrast and the major kind of thrust of this book. It's that the people who are measuring and recording data and trying to develop models that fitted with that data, and then being prepared to revise their models in the light of new data or making predictions which didn't come true as far as measurement went, they had to go back and change their models. Now, if you're believing in tortoises, on the world on the backs of tortoises and the world being flat and a floating disc on water, etc., you tend to, or human beings in cultures have tended to persist with those models and not be interested in confounding data. And this is the kind of tension that runs through this book. It's one of its major themes. So, although the ancients had measurements that were incredibly accurate and therefore very useful for their various purposes, agriculture and what have you, that they still remained interested in the objects themselves in the sky and trying to understand the models, basically, of the models of the universe that lay behind them. Here's what Koestler says: "The most fascinating objects in the sky were the planets, or vagabond stars as they were then called. Only 7 of these existed among the thousands of lights suspended from the firmament. All the other stars remain stationary, fixed in the pattern of the firmament, revolving once a day round the Earth mountain, but never changing their places in the pattern. The 7 vagabond stars revolve with them, but at the same time they had a motion of their own, like flies wandering over the surface of a spinning globe. And it was these patterns that continued to occupy the heavens gazers, from 6,000 years ago through the 6th century BC in Greece. And then all that knowledge was lost in the Dark Ages, Middle Ages, and then developments began again in Europe with Copernicus and Tycho Brahe, and particularly Johannes Kepler, who lived in the late 16th and early 17th century. And he's the hero of this book, really. And Kepler describes his life and his struggles to understand in very heroic terms and beautifully written. Galileo is mentioned later, and his famous confrontations during the Inquisition with the Catholic Church when he's refusing to back down. But Koestler has a less favourable view of Galileo than is often presented. He's mainly a great admirer of Kepler. Now, he describes Kepler's observations of the heavens and his calculations in a lot of detail, and I found it absolutely fascinating, this area. Kepler is working by night often, by candlelight. He even loses his sight just about through all this work in very poor light. And all his measurements fit, except he's a fraction of 1 degree out. And rather than just fudging it or ignoring it or putting it down to some kind of error of measurement, he persists in trying to understand. So the view that the Earth must be the centre of the universe got Galileo into a lot of trouble with the Catholic Church. It was a view that was first developed by Copernicus. The other article of faith that was getting in the way of really understanding how the universe worked, how the planets moved, was a belief in the need for perfect shapes. And Pythagoras was a lot to blame for this. He felt that God would create a universe in which there were perfect shapes, and for Kepler, the perfect shapes were these Pythagorean solids. Can we see that there? Yeah. Look, a cube, dodecahedrons, and these things. There were 5 of them, and he ended up with models where all these things fitted inside each other, and he was trying to fit. There you go. He was trying to fit the descriptions of what he could see in the stars and the motions of the planets. He was trying to say the planets were going round orbits that were fixed on the outside of things like this. Also, he wanted to get back to circles, so right back the Egyptians were drawing circles within circles and saying you can understand the motions of the planet by saying it goes round a circle, round another one, on round this top circle, circles on circles. We're explaining the kind of strange erratic movement that people were observing in the planets. So this drive that the Earth was the centre of the universe and the sun went round it, and that the motion of the planets must somehow be some kind of complex combination of the perfect shape of circles. These 2 articles of faith were getting in the way of building more rational models built more on observation. And it was Kepler who broke the second one, the business about the circles. And in one of his 3 laws of planetary motion, he finally worked out that the planets didn't go in circles around the sun, they went in ellipses, and the sun was one focal point of the ellipse. Now, that's quite technical stuff, but it's beautifully described by Koestler, and he makes all this stuff exciting and interesting, and it's written almost poetically. So you can tell I really, really like this book. I read it back in 1969, as I said, and at the time I was reading physics at university, and in 3 years of physics at university I never heard about one astronomer or one physicist as a person, or about their life, or about the way they went about their studies. Really, all I saw were formulae and calculations and laws. Interesting stuff. But Koestler was one of the first popularizers of science, and it's a brilliant book, and I think it still stands the test of time. Whether all of it is accurate or can now be contested by other historians of science is another matter. But it's a great, great book, and I would recommend it, particularly to people who aren't scientists and want to see some of the fun in this. If you like any of my videos, could you please click the thumbs up underneath? As I'm told, this will help others get to see them. Thank you.